To make a microchip, you start by taking silicon dioxide, usually from sand, and purifying it into ultra-pure, nearly 100% silicon chunks, which is then melted down in a special furnace. Next, you lower a small seed crystal into the vat. Silicon atoms attach to the crystal, extending its structure. Then you slowly raise the seed crystal while rotating it, and this results in a large single crystal silicon ingot.
This is where the seed crystal would be, and then you pull it out.
Can I touch it?
Yeah, you can.
It seems like you would not be able to hold this from here.
Yes.
It even feels fragile, like if you kind of...
Well, snap it.
yeah, I'm scared to break it.
Yes.
He's using more force.
The ingot is then cut into wafers with diamond wire saws, up to 5,000 of them, after which each wafer is carefully polished. Next, it's coated with a light-sensitive material called photoresist. There are different kinds, but in a positive photoresist, the areas exposed to light become weaker and more soluble. So if you shine light through a patterned mask, you can selectively weaken parts of that coating. Then you rinse the wafer with a basic solution to wash away the exposed photoresist, leaving the design imprinted. So now you can actually turn this pattern into physical structures. This is often done by etching into the uncovered silicon by using either chemicals or plasma. And then you deposit a metal like copper to fill in those etched lines. As a last step, you wash away the remaining photoresist, and now you've made a single layer of the chip. We've simplified this cycle down to the main steps: coat, expose, etch, and deposit. It repeats for every single chip layer, and depending on the chip, there could be anywhere from 10 to 100 layers. The bottom layer is the transistors. This is the most complicated layer, requiring hundreds of steps that all need to be perfect. The higher layers are a little easier. These are the metal wires that carry signals and power. By the end, the completed wafer can have hundreds of chips, which are then cut into separate pieces, packaged, and put into products. But by far the hardest and most process is where you shine light through the mask and onto the wafer. This is photolithography. And that's because this step determines how small you can make the features.
At first, it seems simple. Light passes through the